Hey everybody, it's Mr. Morris. We're going to talk a little bit about balancing equations this evening. So the first thing I'm going to do is turn on my little pen here so we can get going. So remember, in order to balance equations, we want to do that to satisfy the law of conservation of matter, which says that matter is never created or destroyed in a chemical reaction. Whatever you start with is what you're going to end up with. It might just rearrange itself. The mass doesn't change, which means however many atoms of one element you have on the reactant side, you got to have the same number on the product side. So remember, just as a quick review, anything to the left of the arrow is a reactant. Anything to the right of the arrow is a product. The little arrow in the middle means to produce. I know that's sloppy, but you can hear as we talk, hopefully. And again, we got a couple of plus signs here. This one means reacts with. And if I had one over here on the reactant side, it would just mean and. And any number that I stick in front of here, whatever those are, those big numbers are called coefficients. So just a little bit of review of all the parts of an equation that we now need to balance. So let's go ahead and do that. I like to do it by drawing a line down the middle and listing the elements that I have. So in this case, I have potassium, and I have 1 on the reactant side. I have nitrogen, and I have 2 on the reactant side. Then on the product side, they formed a compound that contains 3 potassium atoms and 1 nitrogen atom. So in this case, if I compare, I don't have the same number of either element on both sides of my equation, which means I'm going to have to add some big numbers in front called coefficients in order to balance this chemical equation. So I can start wherever I'd like to. I think I'm going to go ahead and start with nitrogen. And if I have 2 on the reactant side, I need 2 on the product side. So I stick a 2 as my coefficient right there. Now that 2 distributes for both elements in this compound. So number 1, I would go 2 times 1, and I now have 2 nitrogens, but I also have 2 times 3, which gives me 6 potassiums. So I fixed the nitrogens, but now I need to go back and fix my potassiums, which is easy because anytime I have a single element, I can save it for last, and it seems to make the balancing go a little quicker. So in this case, if I stuck a coefficient of 6 right there, I would now have 6 times 1 and have 6 potassiums on both the reactants and the product side. So when I compare, I have the same number of each element on both sides of my reaction. So I know this reaction is now balanced. And remember, anytime I leave something blank, it's just understood to be the number 1, which you're more than welcome to put that 1 there to balance that equation. So let's try another one. I'm going to scroll down here just a little bit. So by now you know that this is a combustion reaction. We have a hydrocarbon right here reacting with oxygen from the air, and our products are always carbon dioxide and water. But if you notice, whatever elements I have on the reactant side, I got to have those elements on the product side. And sure enough, the 3 elements I have are carbon, hydrogen, and oxygen on both sides of my reaction. And that is all because of the law of conservation of matter. So let's list what we have here. We have 5 carbons on the reactant side. We have 10 hydrogens. And we have 2 oxygens. And now move over to the product side and say I have 1 carbon. I have 2 hydrogens, and I have 1, 2 from right here and 1 from right there. So I add those together for a total of 3 oxygens on the product side. I'm just going to erase those little circles so we can see better. All right, so my equation is not balanced. I'm going to have to add some coefficients to balance. And because oxygen is by itself on the reactant side, I'll save it for last. So I'm going to go ahead and balance my carbons. So I will put a 5 right there. So 5 times 1 gives me 5 carbons on the product side. I'll wait for just a second. I'll come back to my oxygens here in a minute. Let me go ahead and do my hydrogen. So I have 10 on the reactant side. It means I need 10 on the product side, so I'd also have to multiply that by 5. So 5 times 2 gives me 10 on this side as well. So now I can add up my oxygens. And it looks like I have 5 times 2, so I have 10 of them from right here from the carbon dioxide. I have 5 times 1, so I have 5 of them from the water. And 10 plus 5 gives me a total of 15. So I have 15 oxygens on the product side. So now I come back over to my reactant side and say, what can I multiply by 2? Because here's where I am in order to get 15 oxygens on the reactant side. And the answer is I can't multiply any whole number. I can multiply 7.5, but I can't have decimals as my coefficients in a balanced chemical equation. So at this point I say, okay, this happens. I must need to start over. And in this case, what I'm going to do is change the coefficient in front of the hydrocarbon from 1. Again, it was understood to be 1. I'm going to double it and make it 2. And I'm going to see what that does to everything else. I'm going to go ahead real quick here, though, and erase the mess that I've made. Get rid of my coefficients. And more or less just start over. This happens sometimes. There's really no way around it. The more you practice it, the more you might be aware that it's coming. But again, I'm still probably just going to have to deal with it. So let's see here. If I put a 2 right there, that means I have 2 times 5. So I now have 10 carbons on my reactant side. And 2 times 10, so I have 20 hydrogens. And I still have 2 oxygens. Come back to my product side, 1 carbon, 2 hydrogens, and a total of 3 oxygens. So now, let's try again. I'll put a 10 right here to balance my carbons, and 10 times 1 is 10. I will put a 10 right here to balance my hydrogens, because 10 times 2 is 20. And now I have the same number of carbons and hydrogens on both sides of my reaction. I add up my oxygens. So I'll do 10 times 2, which is 20 oxygens from there, plus 10 times 1 is 10, and 20 plus 10 equals 30. So I now have 30 oxygens on the product side. So now I can come back to my reactant side and say, okay, can I put a coefficient right here in front of oxygen that I can multiply by 2 to get to 30? And the answer is yes. I just take 30 divided by 2, and I get 15, and that becomes my coefficient. So now my coefficients are 2, 15, 10, and 10, and that's the smallest whole number ratio. That's the last thing I want to check, is that are my coefficients the smallest whole number ratio possible? And the answer here is yes. I can't cut 15 in half without getting a decimal, so this is the smallest whole number ratio of coefficients. I have the same number of each element on both sides of my reaction now. 30 oxygens, 20 hydrogens, and 10 carbons, and this reaction is now balanced.